Hi everyone, it's Mrs. Francis, and today we're going to be looking at dilations. Take a moment to pause the video and try the do now. You want to identify each type of transformation as either a rotation, which is a turn, a reflection, which is a flip, or a translation, which is a slide. And so what I hope you notice when you look at the first one is that there is a reflection over this y-axis. For the next one, you're noticing that we have a bit of a rotation here. So we're rotating the blue about the origin. And when we have something like a turn, we call that a rotation. And that only leaves the last one. We are basically sliding the blue to the red. When we have a slide, that's a translation. Okay, so to start the notes, just as a reminder, the scale factor, known as the variable k, is determined by creating a proportion of the image, what you end up with, and the one that is the pre-image, that's the one you started with. So we consider k to be the image to the pre-image. And what we're going to be talking about today is a dilation. Right? A dilation is a type of transformation that changes the size of a figure by the scale factor. In an enlargement, our image gets larger, and in a reduction, our image gets smaller. When we have an enlargement, the scale factor will be greater than 1, and we have a reduction, our scale factor is going to be between 0 and 1. Right, so our first example is an example of an enlargement, and we want to determine the scale factor. And if you notice, the blue figure has just A, B, and C, and the red figure has A prime, B prime, and C prime. So A, B, and C is the pre-image, A prime, B prime, C prime is the image, what happens after we make the change. So if we look at A prime, the value of x is -10. And if we look at A, the value is -5. So in this case, we have a scale factor of -10 divided by -5, which is equal to +2. So we're dilating by a scale factor of 2. And when we have that, we're going to multiply both the x and the y by a value of 2. So if you notice, let me get my highlighter here. -5 times 2 is -10. 3 times 2 is 6. 4 times 2 is 8. 0 times 2 is still 0. And -2 times 2 is -4. So we're multiplying both the x and the y by our scale factor, which is a value of 2. Now for a reduction, we are going to be having a value of k that's going to be between 0 and 1. We're reducing the figure. So we're starting with the pre-image that I'll put in yellow here, and we are going to A prime, B prime, C prime. So for example, we could just pick a different point. This time I'm going to take a look at point B. The image is 2, and the pre-image, x coordinate, is 4. That reduces to 1/2. So we are dilating by a scale factor of 1/2. That means that we would end up multiplying both the x and the y by 1/2. So if you look at this one now, -5 times a half is -2.5. 3 times a half is 1.5. 4 times a half is 2. 0 times a half is just 0, and -2 times a half is -1. That's how we came up with our image coordinates. All right, so moving on, it says dilate ABC by a scale factor of 3. So we're enlarging, so we're going to be multiplying by our value of k. K is equal to 3. So we're going to take each part of our coordinate and we're going to multiply it by 3. So to get our A prime, our B prime, and our C prime, we're going to do 7 times 3 and 8 times 3. Our x part and our y part times 3. Then for B prime, we're going to do negative 3 times 3 and 4 times 3. And lastly, for C prime, we're going to do negative 4 times 3 and negative 5 times 3. And we can write out our simplified versions then of our coordinates by doing that multiplication. We get 21, 24 for A prime. B prime, we're going to get negative 9, 12. And C prime, we're going to get negative 12, negative 15. Okay, moving on. This time we are dilating by a scale factor of 1/4. So our value of k is 1/4. And since that value is between 0 and 1, we're going to have a reduction. Our figure is going to get smaller. So we're going to write in the pre-image values of our x, y, and z. And then we're going to multiply each of those coordinates by 1/4. So we're going to have negative 4 times 1/4. We're going to have 8 times 1/4. And so on. So there we have our final image coordinates. For example 3, we're given our pre-image coordinates of x, y, and z, and we're being told it's dilated to become the triangle x prime, y prime, and z prime. And we want to find out what scale factor was triangle XYZ dilated by. Is it an enlargement or is it a reduction? So we're going to write the image over the pre-image. Now I'm going to go with x prime over x. So for x prime, I have negative 8, and for x, I have negative 4. And negative 8 divided by negative 4 is equal to 2. So k is equal to 2. If k is greater than 1, then we know we have an enlargement. If k is between 0 and 1, we know we have a reduction. So since k is greater than 1, we have an enlargement. For example 4, we're given our pre-image vertices, and we're being told that we're dilating that by a scale factor of 2. So we're going to write down our pre-image coordinates. We have A is 5, 0, B is 2, 4, and C is negative 1, 2. And then we're going to multiply each part of the coordinate by 2. So 5 times 2 is 10, 0 times 2 is 0. 2 times 2 is 4, right? 4 times 2 is 8. And for the last one, negative 1 times 2 is negative 2. 2 times 2 is 4. And lastly, we're going to graph that. So we're just going to plot those points and connect the dots. And that's our final figure. So we have in black our pre-image, and in red we have our dilated by a scale factor of 2 image. All right, so for example 5, I would suggest that you pause the video, and just to outline the steps are right here. You're going to graph the original vertices of the pre-image, and then you're going to apply the dilation with a scale factor of 3. So you're going to multiply all the coordinates, each part of the coordinate, by 3. So to get you started, I would do all my coordinates, do that in one color, and in a different color, I'm going to do my image coordinates. So at this point, I would suggest you pause the video and see if you can finish it yourself, and then when you're ready, restart. And so here we're showing the pre-image, I have it in red, and the image in blue, and that's what you should have seen on your paper when you tried this on your own. Last problem of the day, we're going to graph the image of a square, QRST, after a dilation of a scale factor of 1/3. So first thing we're going to do is write down the coordinates of our square. We have Q, R, S, and T. And now we're going to multiply each of our coordinates by 1/3. I'll do those in red. -9 times 1/3 is -3. And here I would suggest you pause the video, finish the coordinates, plot it, and hopefully when you restart, you have the same picture that I do. Okay, everyone, I hope you got the same picture that I did. Thanks for watching. Have a great day.